Hi, welcome to another session of Circuits and Networks. In today's class 9 under GATE exam, we are going to see some more numericals, that is problems and solutions on dependent sources. In our class 8, we have seen also the different basic dependent sources problems. In today's class, that is starting with problem 1, we will be seeing 0.5, that is voltage dependent voltage source, and I, that is current dependent current source. This kind of problem which was asked in GATE 2022 for 2 marks. So what is the question? In the circuit shown below, the magnitude of voltage V1 in volts across 8 kilo ohm resistor is dash. Okay, so two dependent sources are given in the same problem. So what you have to do, you have to observe carefully what exactly the dependency is given. So I is flowing in 2 kilo ohms and the same I is flowing in 8 kilo ohms, and the voltage it is measured across 8 kilo ohms. So what I'll do, I'll be applying KVL to the two loops as shown. So loop 1 and loop 2 with currents I1 and I2 respectively, I'm assuming to flow in clockwise. In fact, I1 is equal to I2 is also equivalent to I. So this is the important observation you need to see by looking into the problem. Okay, so I1 equal to I2 equal to I. This is the first catch. Then from loop 1, I'm applying KVL. I'm going to get minus 75 plus 2000I plus 0.5 V1 equivalent to 0. With this, I'm going to get V1 will be equivalent to 150 minus 4000I. This I will treat as equation 1. Also, V1 across 8 kilo ohms, which is equivalent to 8 kilo into I. So it becomes V1 equal to 8000I, and this I'll frame as equation 2. I'll substitute equation 2 in equation 1. Then I'm going to get 8000I, which is equal to 150 minus 4000I. So 2 is substituted in 1, and that is how we got this equation. With this, I'm going to get the value of I as 150 by 12,000. This I'm treating as equation 3. Now, substituting equation 3 in equation 2, I'm going to get V1 equal to 8000 multiplied with I, that is 150 by 12,000, which will be equivalent to 100 volts. So this was asked in GATE 2022 for 2 marks, and this is how you need to solve the problem. In the next problem, in the given circuit for voltage Vy to be 0, so here the value of Vy is shown here, the value of beta should be, what would be the value of beta? So clearly, beta Vx represents voltage dependent voltage source, and its dependency is given over 4 ohms, and Vy is assumed to be over this particular node. So applying KCL to two nodes as shown. So I'm assuming these two nodes as Vx and Vy, and applying KCL to first node, I'm going to get Vx minus 6 by 1, that is one branch current. Then Vx by 4, that is another branch current, and Vx minus Vy by 2 becomes a third branch current, and algebraic sum of the currents at particular node is equal to 0. With this, I'm going to get equation 1. Similarly, I'm going to get equation 2, that is Vy minus Vx by 2 minus 2 plus Vy minus beta Vx by 3 equivalent to 0. So these two equations are framed from the given problem. So this was asked for GATE 2021 for 1 mark. Now in the given circuit for voltage Vy to be 0, so this Vy should be made equivalent to 0, then what happens? So from equation 1, if you substitute Vy equal to 0, we will get Vx minus x by 1 plus Vx by 4 plus Vx minus 0 by 2 equal to 0. I'm going to get the value of Vx is equal to 24 by 7. This I'm treating as equation 3. Similarly, from equation 2, if I substitute Vy equivalent to 0, I'll get the value of beta. There's nothing but substituting the value of Vx and Vy equivalent to 0. Vx is 24 by 7. Vy is equal to 0. That is what we have substituted in equation 2. And that is how we're going to get the value of beta, which is equivalent to minus 3.25. Please go through this calculations. By careful observation, you're going to get the value of beta to be equivalent to minus 3.25. How we have done here, once I'm repeating, this Vx is 24 by 7, right? And Vy is equal to 0. So I'm substituting this in equation 2. I'm going to get 0 minus Vx is 24 by 7 by 2, right? Minus 2 is it as it is. Then you have plus Vy is 0, right? Minus beta as it is. Vx is 24 by 7, so 24 by 7 by 3 equal to 0. With this, I'm taking 24 by 7 common. I'm going to get 1 by 2 plus beta by 3 equal to minus 2. This minus is taken common. That's why we are going to get here the value of beta, which is equal to minus 3.25. In the next problem, the current I flowing in the circuit shown below in amperes, round off to one decimal place, is dash. This was for GATE 2019 for 1 mark. It's a very simple problem. It's a current dependent voltage source, and the current is flowing in 2 ohms. In fact, the current you can easily estimate by assuming KCL at this particular node V. So applying KCL at this node V, I'm going to get V minus 20 by 2. This is the one branch current, and this is the 2 amperes, that is minus 2 plus V minus 5I by 3 equivalent to 0. This equation is treated as 1. Also, from careful observation, I is nothing but 20 minus V by 2. Let us bring this equation as 2. Substituting equation 2 in equation 1, I'm going to get V minus 20 by 2 as it is, minus 2 as it is, plus V you have as it is, minus 5. You have I, that is 20 minus V by 2. So whole divided by 3 equivalent to 0. So with this, I'm going to get the value of V. I'm taking V outside. So 1 by 2 plus 1 by 3 plus 5 by 6 equal to 2 plus 10 plus 100 by 6. So V will be equivalent to 17.2 volts. But we need to get the value of I. So I'm going to substitute the value of V in equation 2 so that the value of I will be equivalent to 1.4 amperes. In the last problem, in the given circuit, the parameter K is positive, okay, and the power dissipated in 2 ohm resistor is 12.5 watts. Okay, the valuable information is given. The value of K is dash, and this was asked for GATE 2015 under set 1 for 2 marks. Here you can see I have selected the dotted arrow mark in clockwise direction by assuming a node voltage V over here. So by applying KCL at this node V, I'm going to get V minus 4 by 2. This is the current voltage dependent current source, that is my minus KV naught, and you have 5 amperes which is going away from the node V, so that's why it is plus 5 equivalent to 0. So this I'm treating as equation 1, and I told you I have taken this dotted arrow in clockwise direction so that I'll be getting minus 4 plus V naught plus V equivalent to 0. So by careful observation, V naught is nothing but 4 minus V. So this I'm treating as equation 2. Okay. Also given that power dissipated in 2 ohm resistor is 12.5 watts. So the formula for power is nothing but V naught square by R equal to the value given as 12.5. So this is the formula for power dissipating in resistor R. The R value is given as 2. In fact, V naught square is equal to 12.5 into 2. So V naught will be equivalent to 5 volts. Substituting equation 3 in equation 2, I'm going to get the value of V equal to minus 1 volt. Once I'm done with V naught and V, I'll substitute this equation 4 and 3 in equation 1 so that I'm going to get the value of K, which is equivalent to 0.5. So this is how we need to solve the problems related to gate bits. So you please solve the unsolved problems of previous GATE years papers and prepare accordingly for a coming GATE exam. So in today's class we have seen a problem related to GATE 2022, 2021, GATE 2019 and GATE 2015. I hope you like this class. Please share this video among your friends, subscribe to this channel and press the bell icon for the future notifications. Thank you.